Chapter 1 Fuels, Fuel Definitions, Sources, and Simple Comparison. We can call many things a fuel: scrape food, sugar candy, wood, or petrol. They're all some kind of fuels. So, the definition of a fuel is that it is a substance with stored energy that can be easily released, usually via a chemical reaction, and that is the combustion reaction. Yeah. So fuels can be divided into two categories: renewable and non-renewable ones. What are the difference? Renewable fuels refer to those fuels that can be replaced by a natural process in a short period of time, and that's usually a few decades. That could seem to be a long period of time, but compared to non-renewable fuels, which takes millions of years to replenish, it is far short. Yeah? So renewable fuels normally include biodiesel, biogas, and bioethanol. And these are the three that we need to know about. As to non-renewable fuels, they include crude oil, natural gas, coal. Also, nuclear energy is also non-renewable fuels. Okay? It is clean energy, but it is not renewable. Well, the majority of Australia's energy is produced from non-renewable resources. Okay? So, for the non-renewable resources, there are two kinds that we normally talk about. That is coal and oil. And what are the differences? Actually, they're not much. So, if you look at coals, it's simply dead land animals or plants. They got buried for millions of years under heat and pressure, but because they are on the land, so they become coal. Well, if you're a fish living in the sea, and you die for millions of years, getting buried under the sea, you then will become oils. So it's simply a geographical difference for these two. They're both plants and animals get buried under heat and pressure for millions of years. Okay? For oil, crude oil is an important ingredient for a lot of our products, from cosmetic makeups or your clothes, or of course everything that you feed your car with. Okay? So it is essentially a mix of alkanes, and different alkanes will have different boiling points, and we use that boiling points to separate them. Now, there is something that we need to revise. What determines boiling points? That is intermolecular forces, the forces between molecules. Alkanes are mostly non-polar molecules, which means that dispersion forces will be the dominant intermolecular bonding between them. And if you still remember from Unit 1-2, the larger the molecule, the stronger the dispersion forces. And the smaller the molecule, the weaker the dispersion forces. And the stronger the dispersion forces, it will result in a higher boiling point. Okay, so smaller molecules of alkanes will have lower boiling point, and larger molecules will then have higher boiling point. So you can see that we put crude oil into this tower, and through a process we call fractional distillation. Yeah. So what we do is we heat up at the bottom of the tower, yeah, and then so the temperature here will be the highest. As you go up, the temperature gradually lowers. So what happens is that larger molecules will turn into gaseous state, and therefore being separated at the bottom. And smaller molecules will remain gaseous all the way until they get to the top, because they have lower boiling points. And then they can be separated on the top. Okay? So high boiling points, which is larger molecules, stays at the bottom, and lower boiling points molecules goes to the top. So smaller molecules, so C1 to C4, can be collected on the top. Okay, and the larger molecules, the oils, the oily things that has more than 20 carbons in the carbon chain will be collected at the bottom. So important products from this process includes natural gas, which is the gas supplied to your house, or LPG, liquefied petroleum gas, which is the gas you normally put into your car. Okay? They're mostly propane and butane. Okay. So for natural gas, first of all, remember they are called natural, but it does not mean that they are renewable. Okay, natural gas is not renewable energy. Okay. They're predominantly methane gas with a little bit ethane and propane, so it is a mixture. It's not a pure substance. Smaller molecules of natural gas will allow more complete combustion, so it is better to use natural gas than to use coal. So in terms of sources, they are trapped above crude oil. Okay, so you can see the oils flows at the bottom, and then this is the place where they have little bubbles there, and that's natural gas. Okay, so sometimes they also get trapped onto coals, which is, remember, the fuels that's buried under your land, and they're bonded to the surface of coal, so we can extract them by a process called fracking. Okay. So fracking is it's done here like this way. Okay. So a well is drilled under the ground, and high pressure, which is fracking fluid, will get pumped down into this pipe. So the pressure in this pipe will then fracture the land around it, creating small fissures, allowing the gas to flow out. And that gas is normally a mixture, but predominantly natural gas. And that is what we want. However, there's a lot of controversy around the impact of fracking fluid on the environment, and it is banned in Victoria. Now, fossil fuels, are they good? They are good in terms of energy content. Later, when we compare them with renewable fuels, you will see that they have far higher energy content, which means we don't need to burn a lot of them to get huge amounts of energy. However, their impact on the environment is something of a concern. So we are producing a lot of carbon dioxide by burning fossil fuels. So we release them from the land, we release the carbon from the land into the air, and that leads to global warming, as we already know. And they also release a lot of sulfur dioxide and nitrogen oxide compounds, and they are all poisonous and pollute the environment. Also, the extraction of fossil fuels, whether on the land or in the sea, disturbs biodiversity, and they could also produce toxic waste, like if you use fracking. Okay? And most importantly, they are non-renewable. So we might use them for maybe a day or two, but even that day or two of petrol will take millions of years to form. So they can be easily exhausted. They will easily run out. Okay? So I would like to remember their impact on the environment more as you eat junk food. It's like we're using the junk food to obtain energy on Earth, and it gives you huge amounts of energy but destroys everything that's in your body. So in this case, we're damaging everything that's on Earth.